Hey y'all, I'm Sunny Shell, and tonight, Bree and I are thrilled to have David, Dr. Kastner, and Ceasetoknow to discuss quantum physics, relativity, and philosophy of science. So sit back, buckle up, and let's get to the sunny spot on Skeptic Haven. Hello, how is everyone? Oh, we need to get let's see if I can get her in. There we go. Oh, someone else went out. Who went out? That was David. There we
David.
go.
Yep, there he is.
So
No,
tonight
here.
we have had just a plethora of tech issues, but we're finally on. And I just want to thank all of you guys for coming on. But first, Bree, you're gorgeous. How are you doing
Oh,
tonight?
yeah, you're gorgeous yourself, lady. I rushed in here because we had a little bit of a catastrophe here too. So it's been tech issues on all fronts, and I'm glad we were able to make this happen. Able to get everybody in here and get together for this conversation.
Absolutely. So let's see. We have Ceasetoknow. How are you doing this evening, Cease?
Great, thank you for having me on. Appreciate it.
Absolutely. Really quickly, what have you been up to?
Not too much, just school. Trying to put out more content on axiomsontrial. In fact, I have an episode tomorrow with another philosophy professor who's a friend of mine. Danny Phil Talk is his username. He also has a YouTube channel, so we're going to be discussing things on there. Making more TikTok content, hosting lives, talking about philosophy, religion, that kind of thing. So that's about it, really.
Fantastic. Well, we're so glad that you took the time to be on the show tonight. And David, how are you doing?
I'm doing great. Thanks for having me again.
Awesome. What have you been up to since you were on last?
Well, I just got back from vacationing out of the country and started a new semester. So teaching relativity, so that's going to be fun.
That's wonderful. We're so glad that you came back. And Ruth, I know you and I both have had major tech issues, so I'm glad we're both here. How are you doing this evening? Uh-oh.
Nope.
And she's gone. So we will just go on, and as soon as she's able to come back, we will bring her back in.
She'll pop back in again.
That's right. So I'm excited. We're talking about quantum mechanics, relativity, and philosophy of science. So I know backstage, you guys were talking about consciousness a little bit, and I thought we could just go ahead and kind of start there.
Sure. I think one of the main points of disagreement that I think David and I have is when we talk about consciousness, what is it that we mean? So I take a physicalist perspective on the matter, which I think that consciousness is kind of a physical phenomena like anything else that we can measure. But my view is a little bit different than the norm. I recognize that there is a distinction between what we measure and the measurement. So what I mean by that is there's a thing itself, and then there is our experience of it, and we can apply measurements to what we're experiencing and what we're observing, but the measurement doesn't capture the totality of what we're measuring. And this leads some people to think or theorize that therefore it means that there is something about experience and about consciousness that cannot be reduced to the physical. Whereas I say that measurement is only one aspect of the physical, that it doesn't exhaust what I think is meant philosophically by physicalism. And so it's like looking at a cube from one angle. Like it's not going to be the entire. I guess one thing I would say about it is just because we have certain limitations epistemically it doesn't mean that we should then assume extra ontologies as existing beyond the physical. So it might be more of an issue of what we can know and what we can describe versus what the nature of our reality is. Whereas from my understanding, conversations that I've had with David in the past, I think, and correct me if I'm wrong, but I think you would say that consciousness is kind of fundamental. It's instead of looking at it as being a product of the physical, you kind of put consciousness behind everything else. That it's kind of like there's one thing, and that thing is consciousness. Am I remembering that correctly?
Well, consciousness is one of the fundamental unsolved problems in science in general, and not directly related to relativity or quantum physics. So I was about to get Dr. Kastner in on the action, but she slipped out again. There are people who will try to connect it to quantum physics. But I think most people think that consciousness, they think of consciousness in the way that you think of it, Cease, which is an emergent state that comes from complications or something that's going on in the brain. It's an emergent phenomenon that comes from physical systems, and I have issues with that kind of thing, because emergence in science, emergence specifically in physics, is a very specific kind of thing, where the thing that emerges in some sense lives in a very specific kind of space, which is the same space as the thing where it emerges from. And so those things are connected, whereas consciousness seems to be a very different kind of thing. So to give you an example, temperature is connected to temperature emerges from molecular motion, and you can show how that process works. You can write something down on a piece of paper and connect temperature, describe temperature mathematically, describe molecular motion mathematically. So in some sense, they occupy the same space. But we started off on a sort of on a tangent on some corner, because consciousness isn't directly related to the topic. And Dr. Kastner's in, so maybe we can introduce her, get a sense of her background.
Hey,
Welcome
Ruth,
back.
we're so glad that you're back. So, can you
Thank you.
tell us what you've been up to? If she was able to.
Well, my work is. Can you hear me at all?
Yes.
Can you hear me okay?
Yes.
Okay. Yes. Okay. Well, I keep Chrome keeps asking me, interrupting the stream here to ask me questions about what I want to do with my browser. So every time it does that, it knocks me out. So you need to blame the next time I disappear. Anyway, well, I've been trying to I've been working on what's called the transactional interpretation of quantum mechanics, although it's really a subtly different formulation of quantum theory. And I guess most recently, my second edition of my book on the transactional interpretation came out in 2022. And so I've, that in that edition, I just kind of updated it with my recent work, which makes explicit some of the more technical relativistic developments that kind of fills in some gaps that might have caused some people to wonder, whether it was really complete and so on. So I've kind of filled in some spaces there. I don't know. That's basically what I've been up to. So I'll just let you ask whatever you want to ask.
Well, the first thing I want to ask is, do you want me to call you Dr. Kastner or Ruth?
Oh, Your Highness will be fine. No, Ruth is fine.
Okay.
Yeah, Ruth is fine.
Okay, great. So
Sonia, I'm sorry. I just wanted to mention, and one of the reasons why I refer to her as Dr. Kastner is that she was my philosophy professor many years ago when I moved back to the United States and finished my undergraduate degree and was going to graduate school. I wanted to take some philosophy courses, and I took a philosophy of science course with Dr. Kastner, and then I took another philosophy course as a result of that, and then began my graduate career.
Old friends then.
I will
Yes,
tell you, it's
I
hard.
remember that fondly.
I know some of my professors, and I still can't call them by their first name. So I totally get it. It's that
Uh-huh.
respect, and you just can't do it. So
Yeah, I'm the same way. I can't talk. I can't call any of my
I
professors by the
appreciate
first name.
that.
Well, since Ruth is here,
Gotcha. Well, David was among my best students.
I would not doubt that. What were
No,
you
go
going to
ahead.
say, Bree? I'm sorry.
Oh, I was just going to say, if she would, if she wouldn't give a lay person's explanation of her work, because it's as fascinating as it sounds. I can't keep up with all that. So, like, is there a way to express this to somebody who's not researched in the field that might be, I don't know, that you could lay out for me with
Sure.
quantum mechanics? Yeah.
Yeah. Yeah, sure. I mean, I can give. I actually have written a couple of books for the layperson that really try to do just that. And I mean, I can try to give you kind of the nutshell idea here, but my 2015 book, Understanding Our Unseen Reality, is where I really do try to present it. You know, no equations, just kind of with some graphical kind of conceptual illustrations of what's going on. So basically, what I'll just abbreviate it TI because transactional interpretation, just because it's easier to say. What TI does is it actually uses a different theory of the way fields behave. So in this has been called historically, it's been called the absorber theory of fields or of radiation, or the so-called direct action theory. And you can quantify that. You can give a very specific physical description of what that means, and it's a really different way that fields behave. And the bottom line for our purposes is that in order to have any kind of radiative process for the electromagnetic field, which means the exchange of a real photon, and I don't mean, when I say real, I don't mean I'm just saying that to distinguish it from so-called virtual photons, which are force carriers, and they are not energy. They're not really radiation. So this kind of distinction is hard to make in the standard approach, but in the transactional approach, you can clearly distinguish what is required to get a real exchange of energy, and it actually involves an active response of absorbing systems. And this feature is something that's not taken into account in the standard approach to really all of physical theories. So in that, and I heard a little bit about the opening discussion about measurement and so on, and what the term measurement in quantum theory is notoriously problematic, because in the standard theory nobody can explain what they mean by that term. They can't in a very specific way. They really are unable, but the standard theory is unable to say what it means physically by the term measurement. And this is the measurement problem, the so-called measurement problem. And it's still around, and it's gotten actually even more serious, where people recently have come up with scenarios where, due to the standard theory's inability to define what a measurement is, you get into contradictions and inconsistencies. So it's a very serious problem, and what TI does is it allows you to say, in physical terms, and in terms of a physical theory, what is it that we're doing when we're conducting a measurement? So that kind of, that's a very different situation than we have in the standard theory, because you can really say, you know, okay, I'm going to go into the lab, I want to measure something. You can say, what do I need to do to get a measurement outcome? And did I really get an outcome? Yes, I can say I really got an outcome, and it didn't just end up in a Schrodinger's cat sort of situation with my entire lab in some sort of superposition, which is what you get in this standard theory. So that's sort of a long-winded way of saying, you know, what TI does is it really does, I think, resolve a lot of these kinds of problems that arise from the standard theory, to just kind of assume that fields, or in particular the electromagnetic field, the field that gives us light and radio waves and so on. The standard assumption is that's kind of a pre-existing autonomous entity. And in the transactional, that's not the case. So I'll just kind of break there.
Can I add something to that?
Sure.
Sometimes people get the impression that people who theorize have complete freedom to create and to bring into the picture whatever they want. And I wanted to point out that, and you can correct me if I'm wrong, but you are including in the theory solutions that are already there from the equations that are otherwise discarded. So you're not inventing something out of the blue, but you're using structures, solutions to equations that are otherwise ignored for physical reasons. Am I correct with that?
Right, correct. Yes, yeah, absolutely. So yes, so I mean, what the transactional picture does is that it, in this process of absorber response, which is not sort of part of the standard theory, we get a physical referent for these quantities that actually do appear when you're calculating probabilities, and you always have to sort of use these theoretical entities. You're ending up using these so-called advanced solutions that are called backward in time, but in my approach, they're not literally going backward in time, but they are these so-called advanced field solutions. And yes, as David said, they are already in the theory. And in fact, in quantum mechanics, even though people want to conceptually disallow the idea of advanced propagation, they are forced to use these theoretical entities to get any kind of real valued, you know, probability that describes quantities such as energy and so on. So it's really just, it's not inventing anything in an ad hoc way. It's another way to understand the way fields work, and in so doing, you're gaining a referent, a physical referent for quantities that we help ourselves to anyway. And I'm seeing that I just popped back in, so you may have lost some of that. But anyway, yes, the short answer is yes.
That made a lot more sense. I think, Bre, did that make a lot of sense to you as well? Oh, you're muted.
So yeah, that did. And also, they dropped a link to her book that's available on Amazon. So if you're interested in getting if you're not versed in this topic and you want to get entry level knowledge on it, sounds like it's going to be a great place to start. Yeah.
So I
Thanks.
one of the topics that that was brought up backstage that I kind of wanted us to talk about is the way that kind of the pseudoscience or the woo is kind of taking up the quantum theory or quantum mechanics and trying to make it seem like it goes with their hypotheses that are not really grounded in reality. Is that making it difficult to to continue doing the work that you do?
Well, it does. I don't know. It just sort of. Are you talking to me or
to any of you? Actually,
who's that addressed to? Oh.
Ruth, you can go first. I'll go second.
It is for kind of for me. Okay. It does create some issues for me. I end up sort of being this sort of no man's land of saying I want to critique the standard orthodox approach of the quantum theorists, physicists. But then I also want to critique this what you call the woo, approach to taking quantum theory and pretending that it has something to say about consciousness, which it really doesn't. And so while I'm sympathetic to people who, I think that the issue of consciousness is a very important one, but I do think that it's a metaphysical, as opposed to an issue that you're going to get, you may get some sort of indications about it, about metaphysics from quantum theory, but as I noted, the current state of quantum theory is deeply dysfunctional. So that's kind of an issue that I come where people are using the standard theory to try to arrive at certain conclusions, but the standard theory again doesn't work. Basic way to you can't even say why you get a measurement result. So it's dead in the water in that respect, and then people end up doing the kind of von Neumann thing where they say, well, it's only in the psyche that I'm getting measurement result, but that just doesn't work at all. It ends up, you still get yourself into inconsistency. So it just doesn't work to say, oh, the reason we have a measurement problem is because consciousness. No, that is no longer viable at all.
I just want to add to that the New Age rhetoric, it just functions like a business, like religion has in context in the past. Right? It's about power. It's about selling a product. It's about controlling people, right? And so, people like Deepak Chopra that are infamous for throwing around words and terms that he doesn't even remotely understand what he's talking about. He puts it in a like you said, in a kind of a supernatural and so-called spiritual context, and pretends like the science is in his favor, when the concepts expressed by the physics, which I'm not myself would never dream of trying to lecture anybody about, but they are far removed from the dogmas and narratives that he's trying to push forth. And so, he's trying to sell books, he's trying to sell merchandise, and it's a very dishonest business that he's in. And I would urge anybody listening to this to be very wary of people who pretend to be authorities on these matters, who don't have any background in science at all. They're just charlatans. And so, I think, obviously physics is not my field, philosophy is, but I find the intellectual dishonesty of people like that to be enraging. And so, that's my thoughts on the matter.
And David, would you like to add anything to that?
Sure. I was always fascinated by quantum theory and how to combine quantum theory with the ideas of relativity, but I quickly recognized that this is not something that I wanted to do research on, because it seemed clear to me that this field would be extremely frustrating. And I say that because Dr. Kastner, for example, works on trying to combine quantum physics with relativity, but quantum physics lends itself to all of these different interpretations, and they're all explaining the exact same data. So you can't appeal to data and say, okay, the data that in my experiment tells me that this interpretation of quantum theory is correct and that one isn't. That seems to be very hard to do. They all seem to be explaining the same data. So you have to appeal to good ideas, right? To things like elegance, economy, why you use certain solutions and you don't use other solutions, why that's illegitimate. And then there are subtleties as well. But I have enough frustration dealing with trying to propose theoretical ideas where there is a lot of data. So I look at the data, and I do black hole astrophysics, And I say, look, this idea explains all of this data in this way, in this simple way. That idea doesn't, and yet you'll still see people proposing and publishing an idea that, given the data, is clearly can't work in my mind. So it's frustrating enough for me there where there is data. I can't imagine how frustrating it must be for Dr. Kastner dealing with people who just live in the space of ideas, and you show them an idea and they don't react. They have no pulse, or they don't realize why it's a bad, their idea is bad and this other one should be better. Right, so.
I would love to hear your response to that, Dr.
Can I
Kastner.
just comment? Yeah. Actually, I mean, in a very real sense, the as I mentioned earlier, the called transactional interpretation isn't sort of just another interpretation of the same data. It again is a different theory. So the tricky part is it's empirically equivalent at the level of probabilities. However, the subtlety here is that we indeed have an anomalous situation in the standard formulation of the theory, in that the standard theory cannot consistently predict probabilities under certain circumstances. And these are, if David wants kind of check this out, these so-called Froschiger-Renner paradox, the Wigner's friend paradox. It's based on the Wigner's friend paradox, and that's kind of been around for a while. But Froschiger and Renner recently came out with basically a proof that showed that due to the measurement problem, which is the inability of the standard theory to define what counts as a measurement, you end up with situations where you get into outright inconsistencies. So this, in a sense, is an anomaly. This is a problem for the standard theory that is not a problem for the transactional formulation. So in that sense, it's really kind of analogous to the situation where we had an anomaly in the perihelion of Mercury with Newtonian mechanics. And we already had that anomaly. It's not like it was a novel prediction of relativity, but relativity, Einstein proposed relativity as a model that successfully predicted phenomena that were currently an anomaly for the present theory. And that's exactly what TI is doing. It's predicting that under certain circumstances, you will get a measurement result. Here's why you got it. And when you get that result, it obligates a certain kind of state description that makes it that you will not end up in these inconsistencies. So this makes it, this is a situation now where we have an alternative competitor theory, the transactional formulation, that successfully resolves an anomalous at the level of data. I mean, not data. It's like no one has actually observed these contradictions because they are predicted by a model that doesn't really describe reality. That's all consistent. If you've got a model that predicts you're going to see crazy things and you never do, which is what the standard theory does, then that theory has a problem. And TI remedies the problems of that nature. So it's, again, we're not just sort of in the field of, I got a nice, a more elegant, way of understanding quantum theory. No, this is actually a different theory that rectifies empirical shortcomings in the standard theory.
So how do other quantum physicists, how do they respond to this resolution? Because presumably they don't see it, right?
They ignore it. Yeah. It is so, that's the famous Gandhi quote, first they ignore you, then they laugh at you, then they fight you, then you win. Well, I'm still, the transactional interpretation is largely in the ignoring phase. It often, if I have had some people laugh, do the laughing thing. I've had one philosopher philosopher of science called it fanciful. And then there is a lot of fighting that goes on at the review stage, where often people attempt to kind of block my papers from publication based on criticisms of a version of TI that dates from several decades ago. That's not at all what it is now. And of course, I mean, we have some, so from an earlier time when it was engaged with somewhat, it was there was a kind of a thought experiment raised by Maudlin in the 90s, where he claimed to have refuted, and that became a kind of article of, and of course what he's refuting was just his own proposal of a thought experiment that you actually can't even mount at the relativistic level. So it was an interesting challenge. The Maudlin challenge for TI was an interesting challenge, but it wasn't any fatal, and it has since been entirely defeated. And however, at this stage, all of that information is largely ignored. So it's obviously it's being published, but it hasn't kind of really been allowed to enter the conversation at the level of the orthodox physics community.
Is it fair to say that there's a particular relationship between your interpretation or your theory of quantum physics and space-time that doesn't exist in other theories of quantum theory?
Oh, yes, definitely. Yes, definitely. And I talk about this in the second edition of the CUP 2022. It's in particular chapter 8. So in the relativistic development of TI, which I call RTI now, we have a very specific relationship between the quantum substrate, which I propose that largely what is described by much of the apparatus of the standard theory, that it is actually kind of a domain that, if we want to be realistic, quantum states are multidimensional and they're complex. They have complex amplitudes. And clearly these entities are not space-time objects. What I propose is to take that seriously and say that, okay, much of quantum theory is referring to this domain that is really kind of a source of the space-time construct. So then the space-time construct is emergent from that. Just very simple terms, it's the structured set of measurement outcomes. So in this picture, what you really need kind of metaphysically to entertain picture is the idea that quantum theory, in a very real sense, is describing a form of physical possibility. So, and then you have actualizations of certain possibilities. And this is what transactions are. They're the process by which certain possibilities become actualized. So I discuss this in very specific quantitative terms in my second edition.
So is it fair to say that transactions give rise to space-time?
Yes. And actually this has been developed. I recently collaborated with a colleague on a joint paper now, and I can provide that reference for whoever's interested. It's a development of entropic gravity, which was pioneered by Eric Verlinde. And what it does is it this basic idea that gravitation, which is the structure of space, emerged metrical structure that emerges by way of certain entropic considerations. And when you use the transactional picture, you can really quantify that in a very specific way. And the due credit for this goes primarily to my colleague Andreas Schlatter, who specializes in general relativity, and he's provided what really amounts to a theory of quantum gravity using the transactional picture. So in a very specific way, we have an article that shows you how the space-time construct emerges from the transactional process, and why that structure then acquires the metrical properties that are described by Einstein's equations. So, it's a very this fruit, I think, and I presented that paper at a recent conference in St. Andrews, Scotland, which it was a gathering of people who are working in the so-called MOND program, Modified Newtonian Dynamics, because this theory actually kind of gives you some features of the program where it predicts the phenomena that are usually attributed to dark matter and dark energy. So when you use the transactional picture, you automatically get, yeah, go ahead.
Sorry, I was just going to, you mentioned Mond. Cease had Pavel Krupa on his show a few months ago. He's I don't know if you know Dr. Kastner, but he's a proponent of Mond.
Yeah. I want to kind of jump in here because I think this is where kind of my philosophical concerns,
yes,
where some of my philosophical concerns arise when talking about science and how these notions are expressed. I don't know what it means for something to exist outside of space-time, or for space-time to not be fundamental, right? My understanding is that when we talk about existence, linguistically, it's always been within a context of having a spatial and temporal dimension. Like, that's what it means for something to exist, is to have the properties of being in space and time. So one of the things that I've often said when engaging in religious debates with theists is that when they say things like, well, God exists outside of space and time, my response to that is, I think that's linguistically meaningless, right? I don't know what that is actually expressing, what proposition you're saying. It's like you're removing all the aspects of existence that we understand of linguistically. So I don't understand, in the context of physics, what is meant by there being these transactions that lead to space-time or that are outside of space-time and yet exist. Well, I don't know what it means for potential to exist outside of space and time. And I'm concerned with what is it that is ultimately being expressed in the science when these are the notions that are being brought on. I don't know if either of you want to respond to that.
Well, here we get to, can you hear me okay? Yeah, this, I would like to respond. And now I'm not sure I've got your current name. What was just said by my buddy here, who's a CEO. Okay, cool. It is a particular physical that has become very naturally associated with the term space, and that is the meaning of the term, that in which the term is taken to mean the container in which everything real exists. Now, indeed, I am challenging that definition of the term space-time. And that is obviously a big obstacle for many people, and certainly it has been a basic tenet of many schools of thought and especially science, that the term space-time just means that container in which we all exist, in which everything real exists. And what I'm doing is saying, voluntarily, and some good reasons why that doesn't have to be a necessary meaning of the term space-time. One that many people aren't quite aware of is that general relativity itself actually implies that the sources of the space-time field are outside space-time. So to just unpack that, rest mass is a source of the metrical field in general relativity that is called space-time by Einstein. And in a very strict sense, the source of a field is never in the field. So this picture of saying, matter as in its quantum nature is not contained in a space-time field is physically quite correct and quite accurate and consistent with general relativity. So that, and people, in fact, who work in general relativity and who have a metaphysical picture that everything real exists in a space-time container are actually contradicting the theory. So this is something that's to really, accept, and I get that. But and many times you'll see illustrations where people are trying to show representations of a hunk of matter that's distorting space-time and curving space-time, and they always kind of show like it's in space-time. But if you look at representations that shrink or reduce the three-dimensional spatial component of space-time down to two, you will see that the matter sources are always represented as hovering above or not in it. And that is because that's the correct representation, because they are not in it. So that's an important thing to recognize. The other thing is that they be realist about quantum theory. And we want to note that states are multidimensional Hilbert space structures, that are complex. These are mathematical descriptions are definitely not space-time descriptions. So the minute we want, if we decide that we are going to say quantum theory is referring to something real, then for consistency, we can't say that what it's referring to is hanging out in a space-time container, because the mathematical description just isn't consistent with that. So those are, if you will, two good, physics reasons to question that usual meaning of the term space-time as the container in which we all exist. It's, it looks empirically sound, but again.
Okay, I don't know what happened there. You might going to
okay, I was going to ask a question, but Cease, you were going to.
Yeah, okay, there's two issues with what's being said here. One is that I actually have an issue with this idea of space-time being a container as well, right? Because I think it's almost describing space-time as itself being a type of thing, right? Whereas I don't really know what that means, right? What I'm saying is that when we observe something that exists, it seems to have take up space and exist and have a temporal dimension of some sort. We can describe it as having a dimension of sorts.
Okay, but isn't this very much an intuitive perspective? I mean, your intuitions are all about space and time, and right. So, but then we look at science, we look at the laws of physics, and we see what they are telling us about these things that we have intuitions about, and we start to see strange things. We see features of laws about time that we don't seem to experience. So we look at the laws to kind of get a sense of why time seems to be directed, right? We're born young, we die old, and that feature is not in the laws. We start to learn things about time and space as well from physical theories that take us beyond our intuitions. But isn't that reasonable?
Yeah, but there's a difference here. Look, it's one to say, okay, we have these intuitions, then we have the science and the mathematics that paints this other picture. It's like, okay, well, then what is taking place? Are our intuitions wrong, or is there something about the way in which we're describing these things that is fundamentally problematic? But either way, as long as it's not leading to some incoherent expression, I don't have any issues with the idea that some of our intuitions are problematic, and that we should do away with some of our intuitions. But what does doing away with those intuitions mean if then the conclusions reached are not actually expressing anything that is coherent, that is linguistically coherent, right? So it's one thing to say, okay, well, we don't think the future, we don't experience the future, but here's why we have good reasons to think the future exists the way that the past exists. I can still wrap my head around that to some degree. But when you talk about something as fundamental as existence itself, and then saying that existence or that things can exist outside of space and time, then I don't know what you mean by existing anymore.
Well,
Right?
it's just a different use of the term, right? If there's something more fundamental than space and space and time emerge from something else, then the more fundamental thing is that other thing.
It's one thing
Why
to
is
say
that incoherent?
it's one thing to say that we're using the term in a new context.
Yeah, I agree. It's not incoherent.
To me, it seems like it's not just a new term. It's actually not expressing anything that makes any sense, right? And
Existing outside of existing, it's kind of an oxymoron, and it's built into itself.
Well, that's because you grounded existence in space-time to begin with, and so you're contradicting yourself, right?
Okay,
but if we can ground existence in a different way,
so then explain that different way. Explain a different way in a context that is going to make linguistic sense, and then I'd be happy to accept that if that can be done. But
I'm not sure what it is here. I mean, there are people who are exploring the possibility that space, when you look deeper, it's something completely different than what we think intuitively, right? We think of space as the collection of all possible positions, right? People are exploring space as emerging from what's called quantum entanglements, so strange quantum connections between things, and somehow that's going to lead, according to them in their approach, to notions of closeness, things being closer, things being farther, depending on the degree of entanglement. If they're more or less connected quantum mechanically, then things are end up being closer or further away, right? So there you have a picture of space that's more fundamental. It gives way to something completely different if that picture is right? But there's no incoherence there, right?
I'm not sure that I understand.
Yeah, I would have to agree that, I mean, if I can just jump in, I don't think it's fair to say that this is linguistically incoherent, because again, that only applies if you define space-time as the container in which all real things exist. I mean, existence doesn't have to be, has no necessary link with the term space-time. And again, it even, linguistic concerns are very much tied to our, I wouldn't even call them intuitions. I would just call them the way things appear to us. And to just kind of make the analogy with, look, it's empirically obvious that the sun is going around the earth. We see that happen every day. It's in your face that the sun goes around the earth. That's not an intuition. It's really the way things look. But unfortunately, guys, that's wrong. We found out that was wrong, and we had to rethink the way we view reality. And this, I think, is no different. That it's empirically obvious that we all live in a space-time container. And I'm like, no, I'm sorry. That's a phenomenon. That's the way things look. And our science, our scientific theory, which again is well corroborated at the level of probabilities, is telling us that, I'm sorry, the way things appear, which guided your linguistic, traditions and the kinds of definitions you gave to terms, it turns out to not be accurate. So I just think, we can't use linguistic tradition as a criticism in this case.
But my concern is, so two things, because I think maybe you cut out, I cut out for you earlier. I also have an issue with the idea of looking at space-time as a container. I think there's problems there as well. But I'm not so much concerned with tradition as I am concerned with, I don't have a problem with the idea that we can come up potentially with new ways of interpreting or reinterpreting our reality. But I'm concerned that there's to a certain degree a way in which our perception is inescapable. And so if what we're then describing is can't be expressed in language, then I'm not sure what it is we're ultimately saying. I'm not saying that we have to be stuck on some tradition. Right? But
Okay.
But if you're saying, if you're saying,
Okay. Well, I would say that quantum theory is a language. Quantum theory is a kind of a language. A theoretical apparatus can be understood as a form of language, as a form of communication. And I think what I'm hearing, from you is as a kind of a Kantian sort of approach that tends to kind of deny that knowledge is possible if it isn't couched in the kind of linguistic tools that to kind of describe our sensory perceptions and so on. And that's Kant's view was very much, that knowledge is possible in terms of these structures. And what I'm arguing is no, that I'm denying that. And Bohr did that too. He actually ended up in a kind of an anti-realist stance with respect to quantum theory, because he did insist that the only knowledge you can have is based on these categories.
Well, no. So let me clarify.
So I would just question that.
Yeah. So I think that really comes down to how we're even defining knowledge. I mean, I agree with Kant. I agree with Kant to a degree. The idea that I think, I don't know. I'm not a Kantian, so let me just put that out there. I think that if by knowledge you mean certainty, if by knowledge you mean certainty, then the only thing that I can express I'm certain of is that I exist, and everything else is uncertain to me. If by knowledge you mean justified,
I wouldn't restrict it to.
Well, which is fine, right? That's what I assume, right? But if by knowledge you mean kind of justified
provisional
belief,
understanding,
right? So what I would say is that
I would call it provisional understanding.
Right. So I guess what I'm saying is, and I don't think you're suggesting this. We can't remove linguistics from from what we're doing, right? Because otherwise, what are we expressing, right? The issue is, can we reinterpret or redefine these tools that is language in a way that can still make sense of what it is that we're finding through science? And what I'm trying to understand
is, I think we can certainly do that. I mean, with the tip of the iceberg metaphor, you can illustrate it. You can say, so there are lots of ways symbolically, and ultimately language is a semantic, symbolic system. So there are many ways you can symbolize and represent these ideas. We're dealing with ideas here, and as you say, certainly we use language to some extent to interpret, but we don't have to. You can still use metaphor. You can still use pictures and symbolic representations and so on.
Yeah.
I'm sorry, I think you're suggesting that we are constrained by language.
I think we're constrained by
and I would deny that.
I think we're constrained by language, but I also think we're constrained by the limitations of our own consciousness, right? And so that's not to say that, I mean, I think there are ways to get around that to a degree, and I think quantum physics is a good example of that. It's a good example.
We have gotten around.
But it's one thing to get around. It's one thing to recognize that the basic picture that we assume to be true of our reality is fundamentally flawed, right? It's another thing to then say, now we can express a better version of what that picture actually looks like. Because again, when you say something like existence outside of space and time, again, I'm not suggesting to view space and time like the container. I think there's issues there as well, from my view.
Okay, I think there's an issue here that the language here is being used in relation to mathematical structures. So these mathematical structures kind of take us to some place that is unclear, and we explore math, and we use language to try to understand these mathematical solutions. right? Dr. Kastner said we include certain solutions, other people ignore those solutions. We don't know how to make sense of them. If we include those solutions that are there in the math, then we get a certain kind of picture. Maybe we'll change language, we'll try to understand this within our current language. Maybe we have to change the words a little bit, but it's the math that is the anchor for these kinds of things. We're not just inventing language out of the blue, right?
No. I'm not suggesting that you're inventing anything out of the blue. What I'm saying is that I have a concern with what is it that we're doing when we're applying math in the first place? Like, what is taking place? What is that tool itself potentially problematic and limited in some sense, or potentially leading to expressions that could be incoherent? I'm not saying that they are, that it is necessarily. I'm saying that I am struggling to comprehend the meaning of the sentence. This exists outside of space and time. And if you have a framework which can make sense to me, I'm open to hearing it.
Well,
just
quantum physicists
I
look at
think
measurements.
it only is problematic if you I think it's only problematic again if you want to define the term space-time as referring to what exists. I mean, all I'm saying is that I think that the proper formulation of quantum theory that helps to alleviate the inconsistencies that the standard does have suggests that the term space-time needs to be re-understood as not limiting what exists. It's only a problem, if one insists on that equivalent of term space-time means that which exists. And again, general relativity itself denies that can be what the term means.
So then can you redefine existence in a new context that is apprehensible? That's not the right word. That is comprehensible. I'm sorry. Conceptually and linguistically. If you're saying that the science is denying that existence should be understood in this context, then what is the context that I should understand existence to be?
Well, the science is denying that term existence should be taken to mean is in space-time or is an element of space-time. And instead,
Right.
it is suggesting that, I mean, for these purposes, maybe again, I have to go back to the idea that physical reality is larger than we thought, and it encompasses a mode of existence that we could view as a res potentia, if you will. And I'm not committed to any particular substance. But if it helps kind of get a grip on, well, what could this mean conceptually? One could say the term exist must be expanded to include a modal form of existence. That's actually not a new idea. I mean, Aristotle was even considering, this kind of thing. So that's one way that one can understand it, and to try to acknowledge that there are these different modes of existence, perhaps.
No, yeah, I mean,
can I make a comment?
Go ahead.
The possible and the actual.
So, Dr. Kastner, you mentioned that the source of space-time curvature is outside of space and time. Something to that effect. And I'm trying to understand that. But I mean, the stress energy tensor is a function, has terms that are a function of space, are they not?
So David, what I would suggest is that you read my paper with Andreas Schlatter, and I will be happy to give you that link because we address that exact question, I think, in that paper. I mean, the stress energy tensor source term is for reasons that I discussed, technical reasons I discussed in the paper. The energy component of that is part of the structure. It's not, properly speaking, a source itself, but the rest mass component of the source, a tensor, is, even though something, I mean, I guess even though something can be expressed in terms of space-time parameters, that need not mean that it is an element of space and time. So this is a subtle point, again, that gets to the distinction between the possibility and the actuality. You know, so this is, you know, I think you'll see in very specific terms why we can make use of the idea of these this Lorentzian manifold that can be understood, if you want to, you know, understand it in space-time terms. You can think of it as describing possible events. It's not an obligatory, you don't have to interpret it that way, but it can be helpful to
This
think
is your
of it that
most
way.
recent paper, right? This is your most recent.
Right. Yes. Yes.
I'm going to jump
So
in
that
really.
paper's in Journal of Physics Communications.
I'm going to jump in really quickly. We had some questions
Sure.
from the chat, and I wanted to really quickly pull them in. Producer West said, "What?" And this is a two-part, so I'm going to have to go in two different ones. What things can we say are fundamental to being? It used to be atomic structures with Newtonian physics and space-time, of course, thinking about things. And then the next one. But would we now say that four forces, EM, weak, strong, and gravity, are foundational too? What else might be fundamental? Space-time.
Well, I would say those are great questions. I would say that what quantum theory, you know, as expressed in the RTI formulation, which is the only way I know of to get a clear account of what measurement is, that what this is telling us is that what we call space-time is in fact not fundamental, but what is fundamental to being is this quantum level, the quantum substratum, if you will, that can be understood in terms of rest potentia. So that's what this picture, that's what this suggests. It suggests that at least insofar as we can describe these entities by physical theory, and I don't say, oh, you know, physics knows everything about what's real. I would not claim that. But insofar as we look at physical theory and we say, what does that tell us about the ontology? I would say that it does suggest that the quantum level of a kind of structured possibility is what's foundational. And so that does include the three forces, electromagnetism, the strong nuclear force, and the weak force. Those are aspects of the quantum level. But gravitation, again, is a property of the emergent space-time manifold. And in that sense, gravity is not fundamental, but emergent.
I just wanted to add that the idea of forces is sort of an old way of thinking about physics, and that nowadays we think of fields sort of coming together that mimics that description in terms of forces. And so fields, some people would say fields are more fundamental. And if you want to think in terms of forces, gravity, in the theory of gravity isn't a force. It's a space-time kind of thing, right? So,
I just want to respond to something that was said earlier about modality. So yes, I mean, I'm well aware. I mean, there are different schools of thoughts that deal with modality in philosophy. I'm currently, and again, I'm completely open-minded to changing, different perspectives. But I'm skeptical generally of this idea of there being modalities of existence, unless what it is you're really saying there is, well, there are certain things that are emergent and things that are fundamental, and that is the difference in modality that we may be pointing to. But I'm not.
Yeah, I wouldn't say it's a modality of existence. It is. It exists, but it has. And again, this is where we have to sort of go beyond those traditional formulas of modal concepts, because it's not saying, well, it possibly might exist. No, that's not the meaning here. It's a form of. It's a kind of it goes back to the I mean, I don't want to reduce it to the Aristotelian concept of powers. I don't think that's necessarily an accurate kind of way of formulating it, but it's more in harmony with that than a a modal notion of, well, it's possible that this might exist. That's not what I mean by it. I mean that quantum systems with rest mass definitely exist, and they're very consequential, and they're, again, metaphorically speaking, they're like the submerged portion of the iceberg, where the tip of the iceberg is the space-time, and those potentialities are very consequential, and
Well, I
they
just don't know
give
what you mean
rise
by
to
potentiality.
the concrete phenomena. So
Yeah, but I don't know what you mean by potentiality.
I'm saying, maybe I'll send you that paper that I
Sure.
wrote with Stu Kaufman and another colleague on rest potentia. Is I think
No, I really appreciate that.
that in terms of the concerns you're having, yeah, I think that might address those concerns, at least in terms of what I mean by it. So I'll be happy to send that to you.
So real quickly, I want to thank Dr. Dino for his $2 super chat. We want to thank you so much for that. And he or she or they asks, is space dependent on time, vice versa, or neither?
Well, if you ask me,
What
I
a
would
great
say
question. I'd say that time in a, yeah, go ahead. So go ahead, David.
no.
Yeah.
Go ahead. Go ahead.
Well, I don't want to monopolize the responses here.
Yeah,
Go
there's
ahead,
just a
David.
lag, and that's why it happens like that. Just a little lag.
David,
Sure.
go ahead.
Well, I would just say that space and time are two different kinds of things that, via the theory of relativity, are constrained in a specific way, such that, strangely, the speed of light is always the same.
Yeah, I mean, look, from my perspective, these things are unclear.
I would say that, yeah, go ahead. Yeah.
No, I think that the philosophy of time is an interesting field that I'm only now dipping my toes in, right? I'm trying to kind of understand better what it is that is being said about it in these different fields. My struggle I'm not rejecting any kind of scientific framework. I'm just saying I don't get it, and I think that it's important that we find a way to communicate across these different fields to get to a point where, like, we know what it is we're saying to each other, and that we can make sense of how when we do get underneath these intuitions and find something new, that this thing can be then expressed in a way that is comprehensible. And to just say, well, the math works out, is not enough, because I don't know. Yeah, the math works out great, but what does that mean? What is it telling me that the math works out? I don't think
exactly.
That
I mean, yeah, I totally agree with that. And of course, that's what I'm trying to do is sort of say, well, clearly, at least, the math works in the standard theory to give you probabilities, but it doesn't work out in the standard theory to enable you to explain how you measured something. And then with the help of RTI, you at least can get a physical account of what is meant by the word measurement. But then, of course, the mathematical structure, what is it telling us about reality is what intrigued me in the first place and why I went into this field. So, I agree very, very much with Ceasetoknow that, that it certainly isn't enough to say the math works. And we have much too much of that and of course, that just gives you instrumentalism, a form of anti-realism about the theory, where you're just saying, look, it works, so what's your problem?
Right.
So we are over the hour, and I want to make sure that I'm being respectful of all of your time. I want to say, Dr. Cantor, that I am so thankful that you kept on because I know I'm sure it's been difficult with your phone and all of that, but you have been fantastic. And with the lag, I know that can be frustrating for
Thank you.
everyone.
Thank
But
you.
I'd like to see if anyone has last words that they kind of to wrap it all up. And Dr. Cantor, I think we'll go with you first.
Thank you.
Oh, I said Kantner. It's
anyone who
Kastner. I'm
has any
sorry.
lingering can't. That's okay. No problem. Has the right number of syllables. It's all good. It starts with the K sound. You're doing great. So anyone who has any further questions, concerns, what confusions, please feel free. I always welcome, questions from interested people. I guess my two main websites are, my author website is ruthekastner.org. And then my blog is transactionalinterpretation.org. So feel free to check in, and if there's anything else, if you want me to write down one of those references, I'll be happy to do that. Thank you so much for the invitation. It was really fun.
Absolutely. That was absolutely wonderful. David, would you have anything that you wanted to say?
Well, there's so much more to talk about, but
I know.
maybe next time we can discuss. Time sort of came up at the end, and time in physics, in the laws of physics, there are very strange things about time that are counterintuitive. And one of the things about Dr. Kastner's theory that kind of bothers me is that our intuitive notions of time seem to be kind of restored at the quantum level. And that sort of doesn't gel with the idea that the deeper we should look, biological evolution sort of tells us that the deeper we look, the more counterintuitive things we get. And so that's kind of strange and maybe something to discuss next time.
Absolutely. Yeah, I definitely want to have
not necessarily though.
Continue.
You can sometimes have pseudo problems, but yeah, and I've written about that too, so I can pass that on. Yeah.
And Cease, do you have final thoughts?
No, look, the last thing I'll say is this. Obviously, I believe science is the best tool we have, right? There's nothing I'm saying I'm not trying to undermine science or anything like that. I think it's the best that we got, right? But I think there are real philosophical problems that I think arise with some of the way in which I think science is both done and expressed. And I think that philosophy without science is useless, but I think science without philosophy is blind. And I think that we have to come to some kind of coming together of the two to actually make sense of what is actually going on. And I am perfectly understanding of the idea that we have to do away with some of our intuitions. And I think that's fine. But as long as it doesn't mean that the results we get is something that is inexpressible. And if what the scientists are telling us is that it's not inexpressible, that no, actually you just have to rethink what it is that we mean by these words, and here's what we mean by these words, I'm all for that. I'm open to that. And I think that's fantastic. I just haven't heard an explanation of how we should recontextualize these words in these concepts in a way that I'm actually able to comprehend what's being said. Maybe that's my problem, right? But I think this is why these conversations are important, and I hope to have more of them. Mm-hmm. So that's it.
Well, sure. I completely agree. Yeah. This has been I don't know. I haven't even had to say anything. So for being a host, this was like super simple.
For real, it was. There wasn't much intervening needed. These three kept it lively and interesting. So thank you so much for being so engaging. This has been probably our most engaging panel yet. So appreciate you guys.
Thank you guys so much.
Absolutely. And
so if you, it was really fun.
Great. If you guys out there enjoyed this as much as we did and were riveted by all of this, please remember to like, subscribe, hit the bell, all those cool things that help the algorithms. Maybe do some comments in the chat. Like our wonderful chat people did today. All of that helps. Bre, you want to talk about the patrons?
Ooh, yeah, we do have some patrons to go over here. We got Sydney Davis Jr., Eric Ozols, Ryan, Deneen Murphy, Dan D, Michael Wiseman, Kathy Cotton, Cindy Plaza, Sunny Shell, Aaron Coalson, Phil Calderone, and Jamie West.
Thank you guys so much. That's what keeps the lights on around here is the monetary donations. We really appreciate that. And don't forget, we have a whole lot of other shows on here. We have Secular Soapbox on Wednesdays. We have, of course, Thursdays with the Sunny Spot. Saturdays, we have two shows, the Global Atheist and Women Atheist Unload. And then on Sunday, we have our call-in show, Let's Talk, where you can call in and talk to us about anything that you would like to. We always have a subject, but we will take whatever you guys would like. We have some great opportunities for you if you want to volunteer. We have a whole lot of different things going on. So if you would like to volunteer and help us out behind the scenes, please let us know. You can get in touch with us on any of the social medias. For this panel, I would love to have y'all on again if you would be willing to and continue this. So
Get
we
it
will
more
be in
into the
touch.
time, yes.
Yes,
For sure.
absolutely. And so I would love to do that. So we'll be in touch with you guys. And for everyone else, in the meantime, remember to always think critically. Good night, everybody.
Good night.